Hi, this is Mr. Manley. In this video, we're going to take a look at an application of right triangle trigonometry. If you read the text of the problem and look at the picture, you can see that we've got a ladder sitting against a building. We know how high up the ladder the building sits, 14 feet, and we know the length of the ladder, 17 feet, and we want to know the angle. Perhaps there's some maximum angle that we don't want to exceed for safety purposes, and we're going to calculate that angle. Looking at the picture, I can see I've got the opposite side and I've got the hypotenuse. And within our right triangle trigonometry, the opposite and the hypotenuse is associated with sine. So setting up the formula for sine, the sine of an angle is equal to opposite over hypotenuse. And the angle is what I want to know here. We're calling the angle x if we use the picture. So the sine x is what I'm looking for. And then the opposite I can see is 14, the hypotenuse 17. And then solving for x here, we are thinking about what angle has a sine value of 14 over 17. And the way that we find that is by using inverse sine. So I know let's take a look at this. If I take the inverse sine of the left side, that's kind of like a radical undoing itself, right? If I look at x squared, if I do the square root of x squared, that's equal to x. Likewise, if I do the inverse of sine, the result is x. And I'm allowed to do that as long as I do that to both sides. So doing the inverse sine of this other side. And at that point, this expression here, that's a calculator key in. And hopefully at this point you're familiar with that key on a calculator. You can find the inverse sine key. That's how this is read. This expression that looks like sine to the -1 is read as inverse sine. And we can do that for any of the trigonometric functions. I can do inverse cosine, inverse tangent, inverse secant, inverse cosecant, inverse cotangent. But we've got a calculator key in here, so I'm going to do that. And I get 55.4 degrees. Just a couple of things about this. One is we're going to pay attention to the units. Are we going to round off to the nearest tenth or the nearest whole degree? And what does it say? It says nearest tenth, so we're set for that. And the other thing you want to be careful about, when you key this into the calculator, if you get a number that doesn't make sense, you should be paying attention to that and see that the output that you got makes sense based upon the picture that you're looking at. And if you're getting a number that doesn't make sense, it may be that you made an error in your work, but it also might mean that your calculator is calculating the angle in radians. So you want to be aware of those settings on your calculator and know whether or not your calculator is in degrees or radians, and also how to convert the calculator, how to switch the calculator from degree mode to radian mode. Just something to be aware of.